Hello everyone, I am Joy Patida, a third year undergraduate student at IIT Bengaluru. In this presentation, I will be discussing the work I carried out during my internship. My project focused on building a multi-agent interface to benchmark and compare reinforcement learning algorithms developed by our lab. I will begin with literature review done by me. At the start of this project, I had only a basic understanding of reinforcement learning. So I spent considerable time building a strong foundation. I have watched several lecture series on YouTube, like David Silver's Introduction to Reinforcement Learning. And I read this book on reinforcement learning. In this book, I read in Definitely PPO, and this book is by Sudarshan Ravichandran. The way he has written is very nice. He has example for each RL algorithm. So I like the way. I also read this book, Standard Book of Reinforcement Learning by Susan Barlow, but I like the way of the book. It was way easy to understand than this. And in our lab, we used to have a weekly meeting in which one of the chapter of this book was discussed. So half of this book is also completed by me as it was to be discussed week every week. So this book is also completed half by me. And we prof prof used well, as professor wanted to increase the interaction between the interns and the research group. He he used to so we used to have weekly meetings in which interns used to present a paper. So I also presented a paper. So I read a lot of papers on which I decided to present a paper. Some of these papers which I read are these. I mostly read about multi-agent RL algorithm for cooperative and competitive environment. So these are some of the papers which I read. And this is S2S paper, LOQA, and this is the paper which I presented. So learning with opponent, learning awareness. So I can give little bit uh, information about this paper. I have a PPT of this paper also. So I can give what does this paper do. So basically, this paper arguments that we normally have naive, well, in naive learning. We consider Earth as this as the environment, and we have two learners, naive learners, one and two. In naive learning, what happens that uh, these are parameterized by theta one and theta two, but return depends upon theta one and theta two. But in layer learning, to maximize our return, we only consider theta one. We consider theta two as constant. Each learner consider theta two as a constant. So it uh, assumes the opponent has a static part of the environment. So this false assumption leads to failure in many of the situations. So other suggested the algorithm Lola, in which we instead of considering other agent as a static part of the environment, we consider the other agent as a naive learner, and we derived a lot of equations which I have discussed, but I don't want to discuss those. And he then implemented this algorithm in various types of ways. He implemented in iterated present dilemma, and these are some of the results. And he also implemented this in iterated matching pennies, and he also did a round robin tournament. So from this iterated present dilemma, the interface which I wanted to create had things in common with this iterated present dilemma. So when I, as the author, uploaded the code of this experiments he did on the GitHub, so I looked at that code on GitHub, and tried to make the things he did, the basic things he did in his code. I implemented those. So I learned to make environment through gymnasium by implementing this. I wrote this code for to simulate IPD environment like in that paper. I used state like he defined in his paper, and I learned how to build the environment. And I also implemented Q learning and PPO in this. So I got idea how to implement RL algorithms by writing this code. And then I uh, made environment for my code similar to this in my game. So this was the environment of my game, which I made. But my professor didn't allow me to share how the game works, so I can't share so full game working. I will be showing only the after when I can show matlab, some UI elements which I made. So after game ends, what will be showed. So after the ending of the game, this current code is for discrete setting. The states of this is discrete. I have taken history of the game as the state. So this code is discrete. And this is the interface which we get after the completion of the game. We have option to save the graph and row graph to analyze the performance of each player. So P1 here is trained agent and other two players are playing randomly. In this profit is dependent on the action chosen by all three players. So the, the P1, well, we can see that P1, the train agent, is having the highest profit in this. And we have one more graph for analysis. So this is a little bit of interface which I made. I made a lot of UI changes and UI part in the game. But I can't show that. So this is the code for discrete. And I then wrote the code of single agent continuous state. Well, in this code, the state is continuous and this is continuous continuous state and for a single agent. And then I converted this into multi-agent continuous state code. So I will be showing the what I use, different libraries I use. So in for the making of discrete and single agent continuous state code, I use Gymnasium as the environment. And for RR algorithm, I use table baseline 3 for the PPO and other algorithms to test my code. And to convert it into multi-agent setting and with continuous states, so I use Petting Zoo for it. And as table baseline is only for single agent RL algorithms, I switched to RL link for multi-agent algorithms. So that's the work I did in my internship. I made a lot of changes in the UI, but I can't show the UI changes. And I worked on the game mechanism of the also, which I also can't explain, not allowed. And I also read about lot of work in RL, like the DeepMind's work on the AlphaGo, AlphaZero, Alpha Star, and Mu Zero. The basic difference between these are that AlphaGo was trained on all these three things, and it beat the champion of Go. And then AlphaGo Zero came, which only required rules, and by RL, it used to train automatically. And then came the Alpha Zero. In this, we added Zest and Sobe also, and then came Mu Zero. In this, it didn't require the rules also, so learn on its own. These were the work I did in my internship. So, thank you.